Okay, testing the Laney 60-watt EL34 valves that it came with, see if they're any good. There is the amp. I'm going to test it on this AVO, old AVO valve tester. A beautiful piece of kit. Down here we have the specification for the EL34s for setting it up. Just zoom in a little bit. EL34s, how to set the gauges. 6 volts of course, 13.5 negative grid voltage. You set it on the machine, 250 volts. We're going to test that. Should give 75 milliamps of current flow and 11 milliamps per volt. That is Mullard's design specification. If you ever buy a proper Mullard valve, it comes out spot on. Okay, and here are the two valves we're going to test that came out the machine. They're actually focus. What is it? Pinnacle. There you go to the machine. Set up the gauges. Plug it in there. We set the setting on there as it suggested, 13.5. This will be, when we get there, hopefully about 11, and all the other things are set. This is how you use the AVO. You plug in the valve, it's turned on. You test with this gauge down here, you test for any faults on the valve. Make sure it's no short circuits. It's fine. Check the heater continuity, fine. Check the insulation, no short circuit. You flip it to test and you wait for it to heat up. Valve's heating up, see the red there? Heaters. The meter will start coming up. We've set the current 100 milliamps maximum deflection. According to the book, we've set it exactly to the grid volts. It should come up to 75 milliamps. It's rising very slowly as it heats up. It's not going to get to 75, that's pretty much obvious. It's got stuck at 50 at the moment. Still going up as it heats up. Power valves tend to take quite a while to stabilise. It's about 55 at the moment. While it's still heating up, I'll show you how you check the GM on this machine. You zero the meter with this control here. Bring it down, increase the sensitivity, bring it down a bit more, increase the sensitivity, bring it down to 0, increase it to maximum sensitivity, set it to 0, then flip it. It will keep rising as it's warming up, but anyway, flip it to milliamps per volt. You have to set it to number 1 on here. Number 1, well, it's just under 10 milliamps per volt. According to the book, it should have been 11. We just recheck 0 and see it's drifted out already. It will probably take a couple of minutes to stabilise, but it doesn't matter, we're very close. It's only going to change by a little bit. Recheck, and it's dropped even more. 9 milliamps per volt. That's all. So it's a bit under, but it doesn't matter. If the other one's the same, just means it's slightly less sensitive than the really good valve. Needs just a little bit more pushing to get it to maximum. Still warming up. It's about 9. We turn back the controls to see what it's gone up to on the gauge. 60, no, it's only stuck about 55 milliamps. Well, after 75 milliamps it should be. Now the next most important test is when a valve's heated up. Not only power valves, they often get bad insulation, which causes a lot of problems. If you've got bad insulation leakage, you've got all just be hopeless. A lot of cheap valves you buy from China and that are terrible this way. So especially when they heat up, Now with this knob down here, we check the insulation. Normally the gauge should go all the way over to the left, which is really high mega ohms. So we flip it over, gauge has gone way over, check the heater, yeah, it's gone nicely down, go back, turn it off, and we can check the next one. We unplug this, it's not too hot. We get another one, the other one from the amp, plug it in. We check the that it's got no faults. Yeah, no faults. Check heater, it's working. Insulation good. When it's cold, fully insulated. Switch to test. The starts heating up. You see the red there. Give it a little while. Shows you when you turn your amp on, this is how long the power valve takes to start coming up. It's coming up now. And the other one's only about 56 milliamps. 75 is a really good valve. If you bought a millard or something, that's what it would be. Again, this was on to come up slow. If they're pretty close, then they'll be fine, the push-pull. So you need them close so that they work properly and don't get any hum or anything, because they'll be out of balance. It's coming up. We can test the milliamps per volt, make sure that they should be close. Here we go, we're going to wind down to 0 to test. Increase sensitivity, wind it down to 0. Yeah. This will keep very sensitive around this part. So test the milliamps per volts. They're just under 9, slightly weaker than the other valve. 0 check again. Yeah, it's under 9. It's more like 8.5. Seems to be a bit of imbalance in the sound. Might actually give you the sound you want, but you might not get 100% hum rejection. When they're fully matched, you get hum. It's about still warming up and drifting, so you could use these. They're going to be alright. If there's any hum, you could put some new ones in if you want, but I doubt if there will be. Not the best valves I've ever seen, but they're going to be okay. Still drifting as it warms up. Power valves take minutes to get a little longer to stabilise. Anyway, it's hanging around about 8.5, a bit weaker than the other one. Let's see what the current's gone up to. The other one managed 56. About the same, so it's going to be quite easy to bias. They'll be both biased the same. Let's check the very important insulation. Now it's warmed up. We flip it to insulation test. Very high mega ohm, very high mega ohm. So there's nothing wrong with the valve. So there's the test, the EL34s. We'll test the ECC 83s for them next.